Hey guys and gals, hey guys and gals, how you doing? How are you doing? Thank you for hitting the play button. Appreciate you being here. Turn it up! Turn it up. I love it. I love it, I love it, I love it. Thank you for being here. Thank you for learning. That makes you, yeah, that's just, that makes you awesome. Truly does. In my books, that's awesome. Love learning. Let's go. Okay, I think we should get right to it. What do you think, guys and gals? What do you think? We should get right to it. Okay, where were we? So we were here, yes. Okay, here we are. Flick that old switch in your mind, guys and gals. It's mathematics time. Let's go. Using the old noggin. I love it so much. Okay, so how do we convert 3/4 to a percent? How do we do this? Well, we might have to do a little bit of writing, I guess, on a piece of paper. Okay, I know there's a lot of information we already know. Maybe, some of you don't yet. If you work with enough fractions, like I have, I could go over most of them that I have memorized. 16th, and then 1/8. There's a bunch of other ones. The standard ones, of course, quarters, 3/8, all that. I'm just thinking of the ones that are in between. Whoops. I guess we'll go right to 3/8, 1/2, 5/8, 3/4. Those are kind of the most common. And then, of course, 7/8. And then you have 1, right? 32nd, 0.03125. 16th, 0.0625. An eighth, 0.125. A quarter, 0.25. 3/8, 0.375. A half, 0.5. 5/8, 0.625. 3/4, 0.75. 7/8, 0.875. Let's just say Uh, yes, I know how to use a measuring tape. Okay, and yes, I know how to add fractions. And yes, but that's just working with fractions and a measuring tape. Okay, yes, I've crunched a lot of decimal numbers or fractions. So, yeah, like I said, guys, when you work with them enough times, it just becomes ingrained in the membrane. So I know 3/4 is 0.75. But let's work it out. Let's see if can we get a decimal value just kind of doing basic mathematics. Okay, remember, percent magic number is 100, right? Okay, I'm just trying to figure out on the fly how we could solve this without using the calculator. A calculator. Without using the calculator. Okay, and then that means 100 over 1, right? So what I'm going to do is called reduce, right? I want to make the denominator equal to 1, okay? On this side, especially. So, which equals, I want to take as much meat off the bone. What's that piece of meat? Well, that piece of meat is 4. Because I know 4 goes into 4, and 4 goes into 100. Is this going to work? I don't know. I know we're still working with fractions. Let's see. I wonder if that might work. Well, let's just see what happens, right? Let's just play around with the numbers and see if we can figure things out. Okay, so I'm just going to put everything over top of one large fraction. So we have 4 times 1 times 1. Then we have 3. 3 is just going to be hanging out. We're going to break the 100 apart. Okay, so I'm going to put 4 here because I know 4 goes into 100. How many quarters equals $1, right, guys? How many quarters equal $1? Right, this is basic stuff that you should have kind of stored in the old memory banks, right? This is money 101 stuff, right? You know, it takes 4 quarters to make $1, right? It's no different. The decimal is just a position within the set of numbers, right? It doesn't matter if you look at it as 1 or if you look at it as 100. 25 times 4 is still 100. 0.25 times 4 is 1. Right? The decimal and the zeros don't matter. Like I said, I'm trying to show you guys. You know, you can work with numbers and I don't know how to explain it, but it doesn't really matter where the decimal is. It doesn't matter how many zeros you have. 25, 4 25s work out to 1 or 100. You could have 250, still 25, right? Hope that makes sense. Okay, it's just a matter of the decimals in a different position, that's all. Okay, so therefore equals, our number is 25. Okay? So what I want to do is I obviously want what times 4 gives us 4, that's 1. But we have this extra 1, like I could go 1 times 1. It doesn't really matter. It still works out the same. 1 times 1 is still 1. I don't need to write it. Okay? So I kind of just negated one of them. So we want to cancel. That's the meat off the bones. So that's how we reduce a fraction. Just by pulling the meat off the bones. So we're left with 3 times 25. Okay, all over 1. Okay, so doing that math, let's do the long math without a calculator. 5 times 3 is 15. Again, guys, you know, I recommend you don't have, like, it's nice to have it, the times table fully memorized. Eventually you will. Get your 10 times 10s done. Okay? If you need a times table, I actually have one for you that you could just snipping tool and print off. Okay, so let me bring it up. Sharing is caring. I'm looking for, is it? Yeah, just hold up. Thinking where I put it. Don't worry, I'm organized to a degree. I know where I'm looking. Times table. Okay, there you go. I'm just gonna move this up so that you can actually, so snipping tool, okay, and then just take however much you want. It's up to you. Okay, there you go. Where is the save? There it is. No, what happened? It's weird. Start again. Snipping tool. Snipping tool. New. There we go. There we go. Okay, and then just save it. Okay. That's a floppy disk, guys. Okay, that's not a 3D save icon. Well, it is a save icon, but it actually is a real thing, right? I think before we had the mechanical hard drives, you had what was called the A drive. Okay, just do Google search A drive, 3.5-inch floppy disk. There was even one that before that was called 5 1/4. Now I'm not that old, but you know, I was born and people were using it. So even as a little kid, you know, the adults told me about it. Okay, there you go. Times table there for you. We're going to start on the 13s, but oh, sheesh Louise. Okay, let's get back on track here. Okay, so finishing up. 5 times 3 is 15, or you can go 5 plus 5 plus 5. Still 15. Carry the 1. 3 times 2. 3 plus 3 is 6. Plus 1 is 7. Okay? 75. Okay? 75. There we go. Now we're getting closer. We're getting somewhere. Okay, so what we have is basically, all we've done really is we've taken 3/4 and multiplied it against 100. That's all we've done, guys. Okay, so we get the whole number 75. Okay, that's all we've got. But we still have to answer the question. Okay, convert 3/4 to percent. We're so close there. These are the steps. This is how you do it. Now we got the actual number we need that we can convert to a decimal. So remember, you know, if you've been following and watching, which is great, I hope you have been. Okay. The magic number is 100, right? Okay, the magic number is 100. So when you have to convert a number to decimals, really what we're doing is, I'm kind of running out of room here. I should have cleaned it up, but I'll just write it here. To convert a decimal to a percent, we divide it by 100, right? So when we do that, what happens is the decimal jumps. Okay? So I'm going to go like this, and I'm going to write 75. I'm kind of running out of room, but I'm going to show the work here. Okay, so 70, basically it's 75 divided by 100. The magic number is 100, right? When we're working with percentages, we have 2 zeros on the 100. So, like I've been explaining, and I'll just repeat and go over it again, I guess. When we have a standard regular whole number, the decimal is there, right, guys? Okay. Again, we could write as a trailing 0. Shows accuracy. Basically, we just turned a standard whole number into a decimal value. We have, but it's not our answer. This is not the final answer. We're just talking about where is the decimal, okay? And I added in this trailing 0 just to show, so this is tenth place accuracy, okay? But that's not our answer. So when we divide 75 by 100, we're basically taking the decimal from here and going 2 jumps. 2 zeros, 2 jumps. 1, 2. There. That's where the decimal is. Okay? So, I wanted to show you that. I'm going to put a leading 0 and put the decimal there. And there's our answer, guys. That's kind of the long work right there. Okay, let's drop the yays, because why not? Bear with me, I need some coffee. I just kind of get, I don't know, is parched the word? Parched? When I talk lots. Okay. I wanted to look for something, but oh well. Parched, yeah. Just wanted to confirm. I'm good at, pretty decent at spelling. Pretty decent at writing grammatically correct sentences. Average, I guess, if you will. I know a lot of words in the dictionary. I just gotta make sure I'm using the right. Very thirsty. See, look at me. Very thirsty. Parched. Very thirsty.
Parched.
There you go. Okay, so that's how you do it. That's kind of how you do the long work. We needed that 75. In order to get the 75, we needed to multiply 3/4 by 100, do some factoring, and then finish our work. I always factor before I do my final answer, because it's easier to factor with smaller numbers than it is, you can still do it, but I recommend you factor in the middle. That way because your final answer is going to have large value numbers, right? So then you still have to reduce that. You're just making your brain work more. I guess that's fine, but I'm just trying to make it easier for you. It's kind of the goal. Okay, and then we went 3 times 25. That's our magic number we needed right there. And then it was just a matter of converting it to a decimal. Okay, that's the long work. I'm telling you, it's been a long while since I've been in college. Okay, I wanted to save that guy because he's awesome sauceum, which means I gotta erase longhand. this work today, huh, guys? All right, fine. Okay, so let's just go straight to it. Okay, you've already seen how to do it. So 8. Now, if you don't know how many times, what times 8 gives you 100, I mean, there's a couple of ways you could think of it. We already know, just from the last problem, we know that it's 5 times 4, right? Gives us 100. Okay, so the missing number is right here, right? This is the unknown. Okay, so let's just think of this logically. If this number increases, that means we have to decrease. So that means the value that's going to be here will be smaller. Okay? Right? It's a balancing game. That's another thing I like to mention. Math is kind of like a balancing act. Right? It really is. When you have one side equal another side, that's really doing mathematics. It's like, think of this as like a teeter-totter. Okay? The kids teeter-totter. It really is. Okay. Now, obviously, 25 is not an even number. So, how do we do this? This is where the 0.125 comes from. And then, again, it's just a decimal position, right? Okay, 1/8. Let me show you something. Check this out. When I'm talking about decimal positions, like, numbers are numbers. Okay? And 1/8 is a great example. Okay? I kind of drew that too close. I'll move it. I'll go like this. You have to see the numbers. You have to see the pattern. That's the word. Numbers are patterns. Okay, look at this. So what we're doing is basically we need half of 25. Okay? It goes down. Because here it's doubled, right? Here we went times 2. This is times 2. If we're multiplying times 2, 4 times 2 is 8. That means we have to do the opposite. We have to divide by 2 on this side to get this answer. Okay, which we don't know. Well, what's half of 25? You might have it memorized. You probably do. Long division is another thing I haven't done in a long time. I'm kind of just pulling it out of the old memory banks. 2 goes into 2 1 times, right? Okay, we know this, all right? And whenever you're doing division, subtraction. Always, with times, it's plus. With divide, it's minus. Okay, just correlate the two together. So we have 0. Okay, now I just got to bring down the 5, which is here. Okay, all right. How many times does 2 go into 5? Well, we want to get as close as possible to 5 without going over. Okay, so that's going to be 2 times 2. Okay, which is 4. So I'm going to put up 2 up here. Okay, this is this number, and this is this number. Okay, so I write down 4. I'm running out of room here. Then I have 1. Okay, let me just erase that. So I have 1. Okay, and I have to put the 2 back there now. Okay, so to get the rest of it, we kind of have to, I don't know, you can call it borrowing. I don't know what they call it. But we need a 0 remainder, right? That's kind of the goal, to get a 0 remainder. So we're at 1. So I'm going to add a 0, which gives us 10. Okay, this is the point where, because we borrowed, this is where the decimal comes in. Okay, so it's not really 1.0, but I just wanted to show you that. Okay, so how many times does 2 go into 10? That's 5 times, right? We're getting the answer to 0. That's what we want. A remainder of 0. Okay? And that's why the decimal's there. It's kind of like that extra, well, I don't know what to call it, but that's the steps. Okay? So check it out. Look at the pattern here. Okay? So we just went 25 divided by 2. Okay? Look at it. We have 125. 125. There's the pattern. The only thing that's different is the decimal's just in a different position, guys. Right? The number 125. What makes 125? Isn't that 25 times 8? 8 times 5 is 40. Carry the 4. Am I right? 8 times 5. No, hold up. That's 200. That's even. Stop. Right. I just made 200. That's what I did. I'm doing 200. Let me just think about this. 8 times, how many 8s go into 125? So, 25. We get 4 to make 100. Okay. There we go. We need one more. So it's 5 of them. 2 times, whoops. I'm kind of getting a little off track here, but 25 times 5. Not really seeing the pattern there, but anyways. Yeah, let's just carry on, okay? It's no big deal. But as you can see, there's a little bit of a pattern, right? 125, 0.125, 125. So that was a lot of extra work, it was, guys, but we needed that 125. That's what we need. Okay, just gonna clean things up. So, which means that 12.5, that's the number we needed. That's half of 25. That's why we did all this. Okay, I could have did it on my calculator, but whatever. We'll just show the long work. So if you want, like, I could show you the long work, I guess. When you're multiplying, it doesn't really matter. You just line up these, okay? So 8 times 8 is 64. Put the 6 up here. 16, 17, 18, 19, 20, 21, 22. Put the 2 up. Am I right? Oh, stop. I'm wrong. 8s. I got 8s in my brain, guys. I seen my mistake. That's supposed to be a 5. I already knew it partway through. I'm like, I know I'm doing something wrong. Okay, 8 times 5 is 40. There we go. 16, 17, 18, 19, 20. Is this right? 8 times 2, 8, 10. Okay, I'm wrong here. What am I doing wrong? Why am I getting this all messed up? Okay, 12.5 times 8. 12.5 times 8. I'm sorry, guys. I'm messing things up. It works out to 100. Yeah, that's essentially what we wanted. Okay. Yeah, we're fine. We're fine. We're fine. I'm just tripping here. I don't know why I'm thinking of 125 all of a sudden. Why am I? Okay. I gotta stop and remember and remind myself, the magic number is 100. We're good. This is correct. 12.5 does give it, times 8 gives us 100. Okay? And of course, the decimal, we have one jump with the decimal. How do you figure that out, right? We have one jump with the decimal. There's where the decimal goes. 40, carry to 4, 16, 0, carry to 2, 8, 9, 10. 12.5 times 8 is 100. Because of the decimal, that's why we had to move the decimal there, guys. Right? That's the thing about multiplying decimals. You have to remember, like, you have to count. So with multiplying decimals, I'm not going to show the work, but let's say I had 8.1, okay? Okay, I'm just going to do it on my calculator real quick. 12.5 times 8.1 gives me 101.25, okay? So if you look, when you're multiplying, you just line up the ones. No, you're not lining up the ones. You're lining up the last two digits. That's what you do. Okay? The decimals where they are, they don't have to be in line. Okay? Not with multiplication. Okay? So, but we have two jumps. We have a jump here, and we have a jump here with a decimal. This is how I teach my kid. So you go from here, 1, 2 jumps. Right? Because the decimal is not going to be, you don't bring the decimal straight down. Not when you're multiplying. Okay? You have to count one jump here, 1, 2 jumps. That's how you do the decimal hopscotch when you're multiplying decimals. Okay? I didn't mean to get off sidetracked here, but this is the same thing. We have one jump. This decimal's here, we got no jumps. Okay? That's where the 100 comes from. Okay. All right, so we still have to turn this into a percentage. I know it's a bit of extra work. We could really go, well, we know that 1/8 is 0.125. We would be done, right? Especially if you have it memorized. Okay? We would have it memorized. Okay, but actually we have the 12.5 now, right? We have it right here. We've figured out the magic number that we're missing. So what we had to do was kind of just think about this a little logically. So we know from the previous example, we're kind of backtracking here and getting, back on track. So we know 25 times 4 gives us 100, right? Okay. Now they're asking us for 1/8. Well, okay, now we have 8. So we have to figure out what times 8 gives us 100. Okay? So we had to do a little bit of math, some long division. So we had to go 2 divided by 25, right? Because we know that 25 is a whole number, but it's also not an even number, right? So we needed this value here. So there we go. We have that number. There's our magic number right here. That's the number we needed. Okay. So now I've already written it down, but we still have to go 12.5 divided by 100 to get our decimal value. Okay. Which is this, obviously. So if I show you the work, it's the same thing, guys. Okay, it's a little bit extra work to figure it out, right? This is mental math. This is called making you think. Because I think, I don't want to get on a tangent, but please don't be one of them lazy people. Okay, you're going for, the goal is the end goal here, guys, is to get you to be a 120 plus IQer. That's the goal. Okay? Wiser, smarter, faster, more intelligent. People can think they're smart all they want. Now, I don't want to get on a tangent, okay? So let's stay on topic. All right? Do better, be better. I believe in you guys, okay? You guys are the future. Man, I can't keep carrying and walking around life shaking my head. I want to believe that there's going to be people that continue on in this world, Anyways, you guys, yeah, positive, all right? This is for the future. You guys are the future. So, same thing just like before. 100, it has 2 zeros, okay? So that means 2 jumps. So we're taking the decimal from here, going 1, 2, okay? We're basically doing 12.5 divided by 100. That's what we're doing. So I'm going to clean this up. And hang on. Okay, it was just that I fixed. Okay, I'm going to actually write 0.125. Okay. We're just moving the decimal, guys, right? And that's the other thing I wanted to show you, that numbers have patterns, right? You can see the 125. Those are the numbers. Yes, this is 0.125. Yes, this is 12.5. But they're still the same numbers. It's 1, it's 2, it's 5. It's 1, it's 2, it's 5. That's the pattern, guys, right? You grind with numbers long enough, you start seeing the patterns. Okay, you just do. And then you start familiarizing yourself with the common numbers that go with it, like 8 and 4. Okay, so there's our answer right there. Even though it's already up here, but there we go. I'm going to look at it. I already have it memorized, but let's look at the answer. Oh, I'm being silly. Okay, we've already kind of got it in percent form. That's what we wanted. I basically got it in percent form right here. That is the percent form right there. Okay, just to be clear. Okay, this is the percent form. This is the decimal form. I just want to be clear about that. Okay, so I went a little bit extra in the work. I didn't need to, but the goal was to show you guys the patterns. Okay, all right. I hope that helped. That makes sense, right? I hope so. Again, let me know in comments. I'll try to answer the question, to the best of my ability. All right? Okay, so here we go. Another one. So now we're working with money. Okay, we're working with money now, guys. Changing it up. A lot of different problems. These problems are kind of fun because there's a good variety. Again, a lot of these questions, you might need to do this early, working out a problem, just so you can do a second part of another problem. That makes sense? Okay, all right. Your salary is $10 per hour. Wow. I'm pretty sure minimum wage is a lot higher than that now. Okay? Minimum wage goes up because the rules make everything too expensive, so minimum wage has to go up just to survive, right? Again, I'm not an economics guy, but I know enough to know enough to understand. Okay, your salary is $10 per hour. You get a raise of 40 cents dollars per hour. What is the salary increase as a percent? Oh, okay. So basically, oh man, this seems like it would be a calculator, work it out on a calculator thing versus doing the long work. It's fine when you're working with kind of whole numbers and such. Anyway, so what's basically you get a 40 cent per hour increase. Okay? I mean, it all adds up. It doesn't sound like much. Probably enough to pay the government. This way, with the increase, if you look at it this way, this will help pay the government the taxes, and then this will be all yours. Okay? That's money in your pocket. So the little extra helps, I guess. Doesn't sound like a lot, but so basically the increase, you're gonna be making. I could do the long math, but you guys understand money, right? You know where the 40 cents goes. These are the dollars. These are the cents. Okay. So now you're making $10.40 an hour. So basically, it's saying, what is the salary increase as a percent? Okay, so what you basically would have to do is go like this. It's going to be a lot of long work. So it's a lot. I mean, my point is, doing this kind of stuff is a lot easier, simpler. Actually, we have to multiply it by 100 over 1 when you're working with just whole numbers, right? Okay, so I guess the other way of doing this is just pretend this is 1,040. Okay, that's why I just ignore the decimal. That's what I do, right? Think of it as 1,040. So with that said, let me go like this. I keep going equals because I'm used to doing that. That's why. So we're multiplying by 100. We actually have to divide, right? Yeah. We need this. It's a ratio kind of. Let's see if I'm going about this the right way. To convert to, we need it to as a percent, right? Yes, this is correct. You divide to get a decimal, you multiply to get a percent. Okay, just kind of had to pull it out of the old memory banks. Okay, so we need to reduce this, is what we need to do. I could cancel a 0 here. That'll simplify things, okay? 10 times 100. We could do the long work, I guess. So if we multiply now, you're safe to do this, guys, okay? You could actually cancel zeros. That it simplifies things. So 10 times 10 is 100. Okay, and then we're left with 104 times 1. So we're left with that. We need this as a percent. I don't know if I'm going about this the right way. I wonder if I have to flip the fraction. I'm just thinking about this. 100 divided by 104. Invert that. Yeah, that would be an invert. So there's the number right there. That's the actual number. It's actually 4%. We're kind of actually getting it. Works out to 4%. So, but I have to actually invert the fraction. 104 divided by 100 gives us 1.04. So if we subtract that 1, we have 0.04, and then we multiply that by 100, which gives us the 4%, because we're taking now the decimal from here to here, which is 4. Okay. I don't know what to say. Like, you used my calculator a little bit on that, so I won't lie. Dividing. Yeah, I had to flip it because I wanted that 4. If I did it the other way, I would have had 0.9, right? I mean, I guess I could have figured it out that way too. Let's see, 100. Again, the next thing I was gonna do is reduce these. So I would have divided it by, I don't know, 2 I would have started with, I guess. That would have gave me 50 on the top here, and then half of this is 52. And I could still reduce by dividing by 2. That would have gave me 25. Half of 52 is 25, 26. So what I would have had 25, 26. 25 over 26 by reducing. I know I'm kind of making things smaller here, but that's essentially, I just reduced that. So 25 divided by 26 gave me 0.96, okay? But that's not the increase. We need the invert of it. The invert, because that brings us over to 1. Over 1, right? Do you understand? 25 divided by 25 is 1. That's why I said I need to invert it. So I flipped it, right? Which gave me 1.04. This way gives you 0.96. That's not showing the increase. If you understand, right, there's the 4 right there. That's the difference. 4 plus 96 gives us 1, right? We need that 4. That's the increase, a 4% increase. It's not the whole number. 10 is the whole. 10 is the 1. The 4 here is that increase. Now, don't look at it this way. This 4 isn't the increase. It's a percentage of the ratio. Okay? It just happened to work out to 4%. Okay? So, just so you understand. So, the percentage is 1.04. Okay? Basically, that's the same ratio. If I go 10.4 divided by 10, I should get that same number. Yeah, I do. Okay? It's 1, a whole number. This is the original, which equals to 1. The percentage increase is plus 0.04. Okay, I hope that kind of makes sense. I know that was a lot, guys. But really, the main thing is to get that 4, right? You have to realize it's an increase above 1. I'm not sure how else. Yeah, I'm going to leave it at that. I hope you get it. Okay? Again, you could have just went 10 divided by 10.4, right? You still have to invert it, right? You need to get to that 1. You need to be above 1. So that's why you need to invert it. Does It's actually 10.4 divided by 10 because that takes you greater than 1, which is 1.04. That's the increase right there, 4%. So I minus the 1, minus 1, which equals 0.04, and then I had to multiply by 100 to get the percent. Oops, we're going the other way. 4%. Okay. There. That should clean up things. That should make it clear. Okay. Whoops. Okay. They're starting to, make it a little more trickier, but it's not too bad, I guess. Let's continue. How are we doing for time? Some of these take a little longer than I want them to. Oh my goodness. Where does the time go? We're going to do another one. The other thing, guys, right? Please don't spend so much time on a problem like I've been, you know what I mean? You have to kind of grind through the problems a lot quicker, okay? Just letting you know. Now, how did I lose my spot here? Okay, there we go. All right. So, here's the next one. You're going to the store to buy a drink with, so you're going to the store. You're thirsty. You have $2.05. Okay? That's what 5 cents is. 5 cents is the same as 5 divided by 100. Okay? Right? Because it takes 100 pennies to make $1. Right? Money 101. Okay? When you go 5 divided by 100, 2 0 jumps, 1, 2, gives you 0.05. Okay? So, if a drink costs $1.75, so you're buying, I don't know, your favorite 12-ounce beverage, whatever it is. Let me know in comments what your favorite 12 fluid ounces. What's your favorite? Now, everybody is allowed to have their favorite, okay? So if somebody's commenting and you're not a fan of somebody else's favorite, too bad for you. They're allowed to like that kind, okay? It's called being a person. Not everybody has to like what you like. Too bad for you. I'm not saying this towards you guys, but just in case. You always have that one guy. You know what I mean? Know what I'm saying? Know what I'm saying? Okay. You got $2.05 in your pocket. A drink costs $1.75. Will you be able to buy one? Even the villagers know the answer. Okay, what is it? You have $1.75. Yeah, you have $1. No, sorry, you have $2.05. This is how much you have. It's in your jeans, in your pocket, or in your wallet, or your purse, or whatever it's in. Go to the store. $1.75. They're not $1.75 anymore. I guess the Dollar General would have it. I don't know how much it is, but I mean, things aren't cheap nowadays. I feel for you guys' future. Well, you guys should understand why I would be mad. Because I have a kid, right? I'm thinking of his future. Like, enough with the making everything too expensive. It's just ridiculous. Just settle down. You're not in charge anymore. Get canceled. Enough with your inflation. You were driving the bus, you failed. Okay? That's all I have to say. Alright, so will he be able to buy one? Okay, of course. So all you need to do is go, you have to compare is what you're doing. So is it greater than, is it less than, or is it greater than and equal to, or is it less than and equal to? So the Pac-Man analogy, guys, okay? The mouth always wants, right? Pac-Man. I just think of it as Pac-Man. Waka, 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 waka. Pac-Man always wants to eat the biggest ghost. However you want to look at it, okay? So, and then you compare the numbers, $1.75, right? We obviously know what 1 is. We obviously know what 2 is. The decimals don't really matter. So we know that $2.05 is greater than $1.75. If you have $2.05, you have enough money. I don't know how much taxes will be. Depends on taxes. Let me see. 5% over what do they call it? Goods and services tax is 5%. So 5 divided by 100, right? 0.5. Whoops, 0.05. 5 divided by 100, 0.05 times $1.75 plus $1.75. Yeah, definitely have enough. $1.84 essentially with tax. So there's enough, even with tax. Okay, I am going to write another problem, and I'm going to leave that for you guys to solve, okay? I don't know what's up, but man, either I'm moving too slow. I don't know. Am I, guys? Am I taking too long? Am I over-explaining? Am I explaining just enough? What should I do? I don't know, because I don't know you guys. I don't know what level you're at, right? But these are kind of fun to do. Here we go. Here's another one. Solve. Writing in everything too and all the drawing kind of takes time as well, guys. And I'm trying to make it legible as well. Solve for G. Okay. Solve for G. Oh, I kind of skipped a question. I'll leave 2 questions. Okay. I'll leave you with 2 questions. Which is greater? Which is greater? Well, I'll just use the word larger. They should be pretty easy, guys, for you. Okay, I hope. Again, I recommend you try them out. Don't be hard on yourself if you get the wrong answer. At least you're trying. That's more than I can say about, like, I don't want to get on a tangent, but I don't know, I'm a bit of a realist. I think people are lazy, right? So there's probably only 1% of the world that's actually willing to do mathematics. Okay? It's frustrating for me, I won't lie. Okay, what is larger? Which is larger? 0.76 or 0.07? You probably already know the answer just by looking, but practice turning these into percentages, okay? Turn them both into a percentage. Show the work. You probably know the answer, but show the work, okay? And now let's finish the other one here. Solve for G, okay? This is gonna be like, remember, you're gonna have to, okay? Again, you guys could, if you want, you can make your own if you want, or you can just copy mine and print it off. Okay? It's up to you. You can even cut it in half and connect them together, do a little scotch tape origami, whatever you decide. Okay? So let's finish. You're going to need that. I'm telling you, you're going to need this for this problem. That's my hint. It's going to be a little bit of a tricky one, but let's see if you get it. Okay, that's it. 3 minus G equals 15. Okay, solve for G. Basically, you want... I'm going to leave it at that. Okay, without any... I believe in you guys. I think you could do it. It's basic. I don't know, is this algebra? Sure. I'm telling you, this is really this is basic algebra. Okay? Alright. Thank you for watching. You're awesome sauceum. Okay? Letting you know. Look in the mirror, look at yourself, and say, I am awesome sauceum. That's right. Believe in yourself. Let's go. I'll see you guys in the next video. Take care for now. Whoever you are, wherever you are. Again, keep being awesome. Peace.